Hello everyone, welcome to Raos Academy. See, today we are going to discuss about atmospheric structure and composition, very important for your prelims UPSC 2026. So let's start the session. First we will discuss few topics, then we are going to discuss these PYQs. Next, atmosphere. Atmosphere. What is atmosphere? Atmosphere is a thin envelope of gases surrounding our earth. How earth is having layers? We have discussed interior layers of earth, crust, mantle, core. Same like that, atmosphere is also having layers. It is a thin envelope surrounding the earth held by gravity, essential for life support, very important, oxygen and climate regulation, protection from harmful radiation. Stratosphere, it absorbs UV radiation, ozone layer. Without ozone layer, UV radiation absorption is not there, means you don't see any terrestrial life. Next, composition of atmosphere. See, we have two types of gases. First, composition, permanent gases and variable gases. Permanent gases are present in constant proportion, means their percentage is not that much changed. But when you take variable gases, variable gas based on the climate change, based on the other things, the proportion is changed. First, permanent gases, nitrogen, controls combustion and protein formation. In nitrogen cycle we will see protein formation, and plant growth nitrogen is very important and it controls combustion. Next, oxygen, responsible for respiration and it is used in combustion. It is highly reactive. See, nitrogen is around 78% of nitrogen is present in atmosphere because it is inactive, it is not inflammable. But when you take O2, oxygen, it highly combusted, means highly Next, we are going to see the percentage. First, nitrogen 78.08%, oxygen 20.95, means around 21%, argon 0.93, carbon dioxide 0.03, around 0.4%. First nitrogen, next oxygen, next argon. Next, variable gases change with time and place. Here water vapor varies from 0 to 4%. Why 0 to 4%? Why you will see change? Because in humid regions you will see more water vapor content in the atmosphere, high evaporation. In dry places you will see less water vapor in the atmosphere. Based on the region, based on the latitude, water vapor varies from 0 to 4%, but this 0 to 4 less percent, it is responsible for weather. Yes. See, carbon dioxide, it's greenhouse effect. Sorry. Greenhouse effect, water vapor, weather and precipitation, very important for climate and vegetation processes. Ozone absorbs UV radiation. Methane, potent greenhouse gas. Nitrous oxide, climate regulation. See, greenhouse gases are very important, but natural greenhouse gases are very important, but if we enhance them, if we increase the percentage of greenhouse gases, what will happen? Warming. If greenhouse effect is not there, what we will see? Warming effect is not present on the earth. That warming effect is very important for plant growth and other things. But if we enhance them, if we increase that greenhouse gases emissions, what will happen? Global warming. Global warming, climate change. We are going to see. Next, particulate or aerosols. Aerosols, dust, smoke, sea salt, pollen ash, These are very important. They act as a condensation nuclei for cloud formation. Cloud formation, in cloud formation they act as a condensation nuclei. Next, composition we have seen permanent gases, variable gases and dust particles. Most of the students, they forget about dust particles. They think atmosphere is made up of only gases. No, dust particles are also present, that you have to remember, and that dust particles, aerosols, play a very important role in cloud formation and rainfall. Next, structure of atmosphere. First we are going to see the vertical layers from down. Troposphere. First layer is troposphere, next strato, next meso, next thermo, next exo. This you have to remember, and this line indicates the temperature change. That line indicates the temperature change. Troposphere extends at average 0 to 13 kilometers, but at poles it is 8 kilometers, at equator it is 18 kilometers. Here at poles the layer troposphere is 8 kilometers, till 8 kilometers, 0 to 8 kilometers. But at equator, what they are saying, at equator it is from 0 to 18 kilometers. Why? Why this difference? We have seen this difference. On an average it is around 12 to 13 kilometers. It is a lowermost layer. Yes? Because here you will see, for example, this is place A, this is place B, this is at equator, this is at poles. 18 kilometers, here 8 kilometers. Why this much difference is they are asking. Reason you have to know, because they can ask in statement based question. Why troposphere is above when compared to poles, equator, why troposphere is situated from 0 to 18 kilometers. Why? Because here you will see vertical convection. Vertical convection. Vertical convection, air continuously rises, because here you will see high evaporation, intense solar radiation, because of that here you will see thicker troposphere, air rises, vertical convection you will see at troposphere. That's why tropopause is at 18 kilometers. Main reason, solar heating, air expansion, you will see strong vertical convection. Strong vertical convection you will see at equator. That is the reason you will see tropopause at 18 kilometers at equator. Poles 8 kilometers. You don't see that much strong convection over poles. Next, 75% of atmospheric mass is present in troposphere. Almost all weather phenomena you will see in troposphere layer, very important. And this thing you have to remember, temperature decreases with height. Normal lapse rate means whenever temperature decreases with height. Now I am standing here, when I am moving up, temperature decreases with height. Temperature, that is known as normal lapse rate. Approximately 6.5 degrees per every kilometer, you will see 6.5 degree temperature decreases for every 1 kilometer. That is known as normal lapse rate. Here in troposphere, you will see this normal lapse rate. Upper boundary tropopause. Upper boundary, tropopause, normal lapse rate that you have to remember. Now, one more thing, air temperature at tropopause, at equator is more, at equator you will see less temperature or more temperature. Here at 18 kilometers, around minus 80, here around minus 45 degrees. Why ma'am? Why you will see less temperature at poles? Here minus 80 degrees is more less than poles. Why? Because in troposphere what you will see, normal lapse rate, means height increases, temperature still decreases compared to poles. Here the height of troposphere is less, but here height of troposphere is more, means from 8 to 18 when they move up, temperature still decreases. In troposphere temperature decreases. So that's why at tropopause, at equator temperature is less compared to poles. Most of the students, they make mistake here. At poles, because of the cold temperatures, they think at tropopause the temperature is low. But at equator, at tropopause, that you have to remember, at tropopause temperature is less compared to poles because of normal lapse rate. This reason also you have to remember, because nowadays they are asking statement 1, statement 2, whether they are asking statement 2 is correct explanation of statement 1. If they have given in statement 1 at tropopause at equator, temperature is less compared to poles, and in the explanation they have given normal lapse rate, means explanation both statements are correct. Next, stratosphere from tropopause means around 13 to 18 kilometers to approximately 50 kilometers, Here temperature increases with height, this you have to remember. Their normal lapse rate, here negative lapse rate, means here around 6.5 degrees temperature increases with 1 kilometer, means as you go up, for every 1 kilometer you will see 6.5 degrees temperature increase, means negative lapse rate. Normal lapse rate decreases, temperature decreases, that you have to remember. Negative lapse rate means temperature increases with height. Why temperature increases? Because in this layer you will see UV radiation absorption. Ozone layer is present. Because of this UV radiation absorption, temperature increases with height. Contains ozone layer weather free zone. Because of the weather free zone, almost all clouds absent. Only few important clouds like polar stratospheric clouds, that too you will see in winters at cold climate times. Special clouds, they are special clouds. Weather free zone ideal for jet aircrafts. Next, upper boundary stratosphere. Third layer mesosphere, very important, 50 to 80 kilometers. Temperature, again here temperature decreases. Same, tropo temperature decreases, strato temperature increases, again meso temperature decreases, means here again you will see normal lapse rate. Normal lapse rate, coldest air around approximately minus 90 degrees you will see. Meteors burn here, that you have to remember. What is the role of mesosphere? We will see meteors. Meteors burn here, upper boundary mesosphere. See, when you see the structure, how earth, means how beautifully all the structures, each and every layer they are having a unique function. That's why Earth is unique compared to other planets, because of this ozone layer, because of this mesosphere. If space debris comes onto the surface, we cannot survive, right? Space debris is burned up in mesosphere. Again, ozone, harmful UV radiation, they are absorbed in ozone layer. Next, troposphere is responsible for precipitation, condensation, all the weather patterns. Because of that, we are having water, all the cycles, nitrogen cycles, everything, all the cycles, they take place in troposphere. Weather conditions. Weather conditions, if weather conditions are not proper, you don't see any vegetation. If vegetation is not there, oxygen respiration, everything is not possible. Next, thermosphere around 80 to 400 kilometers. Temperature rises rapidly from thermosphere. You will see negative lapse rate. Temperature rises. First decrease, increase, decrease, then continuously you will see increase. That you have to remember. Contains ionosphere. Ionosphere is a special area. Parts of mesosphere also present here. Plus thermosphere. Responsible for radio communication. What happens in ionosphere? It is rich in charged particles. Because of these charged particles, it reflects this radio frequency. It reflects frequency. Because of this, if this is point A, point B. Ionosphere. These charged particles, they reflect. If here one tower is there, here one tower is there, they reflect. Because of this reflection, you will see radio communication. Here you will see the communication. High frequency waves, low frequency waves, and medium, based on the layers like D layer, F layer, different types of layers we are having. And one more thing, here what you will see, International Space Station is present in the lower ISS. Lower layer, what you will see, International Space Station. And one more thing, auroras occur here. What are auroras? We have seen northern lights, southern lights. Auroras are nothing but northern lights and southern lights. Auroras are developed due to interaction between, they are not clouds. This you have to remember, auroras are lights. Northern lights, bluish or greenish, we have seen, sometimes we have seen in news. Auroras are interaction between, they are produced because of interaction between solar flares and Earth's magnetic field. Solar wind and Earth's magnetic field. Because of these two interaction, we will see northern lights. Charged particles, what happened? Charged particles from solar wind, they guide this Earth magnetic field, they guide these charged particles towards poles. When these charged particles, they interact with nitrogen, oxygen or they collide with nitrogen and oxygen, you will see different types of light emissions. Those are known as auroras. Auroras, aurora borealis is related to Arctic region. Auroras australis is related to Antarctic region. Okay. Next, exosphere. Thermosphere clear. Next we are going to learn exosphere. Exosphere, ultra thin atmosphere merges into space. That much we don't, means above 400 kilometers, outermost layer. extremely thin air you will see gradual transition into space. Main thing, temperature, normal lab state or negative lab state, that you have to remember, and you have to learn about ionosphere and thermosphere. Main thing, auroras are not clouds, that you have to remember. Next, satellites in exosphere. See, troposphere temperature decreases, stratosphere increases with height, mesosphere decreases, thermosphere increases. Very important. Next, composition based classification. We have seen vertical like tropo, strato, meso, thermo. Next, composition based. Homosphere from 0 to around meso, around 90 kilometers, you will see uniform composition. Tropo, strato and mesosphere means here uniform composition and they are mixed. You will see turbulent mixing in this homosphere. In heterosphere, gases are stratified by weight. Nitrogen layer, oxygen. Based on their weight, gases are stratified. Means here you don't see any differentiation, all together uniform, mixed. Here you will see stratified, different layers. Different, hetero means different, above 90 kilometers. Light gases dominant here, hydrogen and helium. Next, ozone layer, stratosphere, weather, all weather conditions, troposphere, meteors burn, mesosphere, auroras and radio waves, thermosphere, satellites, exosphere. This you have to remember. Now, next topic we are going to learn about solar radiation, heat budget. Solar radiation, heat budget and temperature. Earth receives energy from sun, first thing that everybody know, and whenever you take earth always wants to be in equilibrium, and when you see earth radiation and solar radiation means incoming solar radiation is known as insolation. Incoming solar radiation is known as insolation. When you see so sun emits the radiation, and even earth also it will emit radiation. This incoming radiation is known as insolation. Here sun and earth follow give and take policy, and after giving and taking they maintain a budget, they maintain in a equilibrium. They maintain balance. That balance is known as heat budget. How they maintain this balance we are going to see in heat budget. First, amount received by earth is not same. When you take equator, when you take poles, it is different. Incoming solar radiation, here when you take earth, now sun. See, sun rays are not same at all the places. Here at all equator you will see vertical, here you will see slant rays. Hot places they absorb more insolation. Solar heating is more at equator, but at poles the solar heating or solar insolation or incoming absorption, that absorption is less. And earth receives solar radiation in short wavelengths and earth emits in long wave radiation, mainly IR radiation. Mainly IR radiation you will see here, UV radiation. This IR radiation, some of this IR radiation is absorbed by greenhouse gases. Because of this greenhouse effect, you will see, means earth neither gets too hot nor too cold. It maintains balance. This heating effect, this GHG effect, it warms. CO2, methane, all this greenhouse effect. See, why temperature varies? First thing, rotation. Why temperature variation you will see. These factors very important. First, rotation on inclined axis. Inclined axis. Why rotation on inclined axis? See, when you take, for example, this is earth. Now, without any inclined axis, earth is rotating like this. Now, rays are coming like this. Continuously equator receives more radiation compared to poles, means you don't see any variation in the seasons, right? If this axis is inclined, for example, this is 0 degrees. Now this axis is inclined. Because of this inclination, now you will see equator like this, all the latitudes like this. Like this, inclined position. Now it is rotating. When it comes here, continuous vertical radiation you don't see on equator. Because of this incline, angle of inclination of this sun rays, what happens? You will see seasonal variation of day and night time. Season variation, yes, on inclined basis. Now it is revoluting, and when it comes here, at Tropic of Capricorn you will see more radiation. Here at Tropic of Cancer you will see more solar radiation, means here you will see summer, but here you will see summer after 2-3, and when it comes here during March at equinox you will see more solar radiation absorption, direct falling. Summer solstice, winter solstice, all this we are going to see because of this rotation on and inclined, because of this tilted axis. Because of this tilted axis at 23.5 degrees you will see variation in the length of day and night time. Seasonal variation you are going to, just rotation you don't observe any variation because of this tilted axis. Now sun rays In northern hemisphere you will see different seasons, in southern hemisphere you will see. When this earth moves here, in northern hemisphere you will see different seasons, here southern hemisphere you will see different seasons, because of incoming solar radiation is absorbed differently. Next, passage of solar radiation. Passage of solar radiation is also very important. See, solar radiation is falling on equator vertically, but it has to pass to reach the surface, right? It has to pass to reach the surface because of scattering, absorption, reflection. At equator, for example, simple question, surface insulation for example, if I ask surface insulation is greater at subtropics or tropics or at equator or any other place. Surface insulation is high at subtropics because at subtropic high pressure zone you will see clear, at subtropics clear skies you will see. Here you will see clouds. Because of that clouds reflect the radiation. Because of that surface insulation is high at subtropics. This is the trap statement. Subtropic surface insulation is, see, incoming solar radiation rays are falling, but on the surface how much radiation is absorbing is more at subtropics compared to equator, because at equator you will see continuous cloud formation. Equatorial climatic zone, tropical, almost throughout the year you will see rainfall. Because of that high convection, cloud formation, air is rising, high evaporation, all these things you will see. Means based on the reflection, scattering, absorption, you will see difference in temperature, solar insolation. And one more thing, because of albedo effect also. What is albedo effect? Rays reflected from Earth's surface. Rays reflected from Earth's surface, but this albedo effect is high in white, like snow covered areas, means whitish color or white color, light color areas reflects more, high reflection you will see, like thick clouds, more reflection. High you will see in high snow covered areas. Low, darker ones absorb heat, lighter ones they reflect, but darker ones they absorb heat, like soil, oceans, etc. Means albedo effect is low in soil and oceans, high in snow covered areas, clouds. Because of this albedo effect also you will see incoming solar radiation, difference in temperature. See, in cloud, suppose this mountain is snow covered or Antarctica, snow covered here. Now it is reflecting back the radiation. Now this surface is not absorbing compared to the soil or ocean. Here temperature will be low compared to ocean place. Like that albedo effect affects the temperature variation. Next, we have seen natural and enhanced greenhouse gas, naturally occurring, human induced emissions. Here, naturally occurring greenhouse gases, what it maintains heat budget because it absorbs IR radiation. Here, it disturbs heat budget. Because of this disturbance, you will see more warming effect. Because of this more warming effect, you will see climate change. Next, impact, it is life supporting, it is global warming. Now, distribution of temperature difference. We are going to see distribution of temperature. Distribution of temperature, we have two types, horizontal distribution and vertical distribution. Horizontal distribution, variation of temperature from place to place on Earth's surface. Here, this horizontal distribution is represented by isotherms. Very important, we have to learn isotherms. Next, vertical distribution, variation with height. With height in the atmosphere, we have seen represented by lapse rate, normal lapse rate and negative lapse rate we have seen. Isotherms, here we factors, latitude controls insulation, we have seen equator and poles. Altitude, here temperature decreases, normal lapse rate in troposphere, right? Land, sea, moderate and extremes. When you take land heats and cools very fast. Land heats and cools very fast compared to sea. At sea, at coastal areas, you will see moderating effect. That's why when you take Mumbai and Delhi example, see, Mumbai is also emitting more pollution. See, in Mumbai also you will see pollution, more pollution. But in Delhi also you will see more pollution. But because of this coast, because of the sea, you will see dispersion of pollutants. Here the land is closed. You don't see any sea effect. That's why Mumbai, you will see moderating it. Delhi, very warming because of land. Land heats and cools very fast and it cools also very fast. Here, sea, no, you will see moderating influence. Water does not cool or heat very fast compared to land. Next, currents, ocean currents, warm and cold ocean currents. Because of the warm ocean currents and cold ocean currents, they move from one place to another place. Because of that, you will see temperature variation. Next, winds, air in motion is known as wind. Now this, suppose here warm wind is there, warm surface, and this wind travel to some other cold area. Now this warm wind transfers heat in this cold area and the temperature difference you will see. See, heating and cooling of the surface, heating and cooling of atmosphere is done in 4 processes. First one is conduction. When two unequal temperature bodies means when two bodies of unequal temperatures are in contact, heat transfer. Suppose here the land is hot. Now the air is moving like this. Now when this air comes in contact with this warm surface, What happens because of the conduction? The heat is transferred to this air. Heat is transferred to this air. Means best example when you take warm bowl, when you touch, the heat is transferred from that bowl to your hand. Here one is stable. Lower levels. This transfer of energy continues till both attain same energy. Till both attain same energy. Next, convection. Second one, convection. Convection, vertical rising, air rises vertically. Air rises vertically. Here horizontally, whenever two unequal bodies of two unequal temperature bodies comes in contact, they transfer that heat. Here the air rises vertically here. Convection. When heated air is light. When this light air rises vertically in the form of currents, that is known as convection. Here transfer of heat you will see vertically. Transfer of heat vertically you will see. Next one is advection. Horizontal movement of air. Horizontal movement of air. Here, warm air to cold place, cold air to warm place. Because of this movement, you will see temperature differences. Next is radiation, that we are going to discuss in heat budget. Next, clouds, control diurnal range, diurnal day temperature range. If clouds are thickly formed, you will see low temperatures because radiation is reflected back. Because of that radiation, you don't see surface insulation, surface absorption. Now these clouds are obstructing the solar rays. Now these clouds are reflecting back. So here in this area you will see low temperatures. Low temperature. Clear skies, high temperature. Clear skies, high temperature you will see. Okay, tomorrow we are going to continue.